So in this question, I'm going to focus on looking at sample question on what we discussed under, ionization, forming up of ions, whether positive or negatively, charged particles. Now, if you remember a few concepts that I talked about there, okay, before we look at that, let's read the question. It says the following table shows the structure of 4 particles, P, Q, R, and T. So you can see the particles, the number of protons, neutrons, and electrons in each of those particles. So it's important that you get to study that. And the question says which particle is a neutral atom. So I want you to say which one is a neutral atom. Now, if you remember in my previous discussion, I did mention to say that when we say an atom is neutral, when we say that an atom is neutral, it simply means that the number of protons will be equal to the number of electrons. So the number of those that are positively charged should be equal to the number of those that are negatively charged. So if you look at that, which particle where the number of protons is equal to those that to the electrons. So if you look at the table here, if I look at this is 11, that is also 11, protons 11, and Q has 11, and also that one has 11. So therefore those are actually what we are calling as being neutral particles, meaning they have neither gained nor lost electrons. So in this case I could have talked about P, and if I wanted Q, so which particle is a neutral atom? So these, because the number of protons is equal to the number of electrons, that's the reason why we are saying that those are neutral atoms. All right. Then the next one says which particle is a negative ion. So which one is a negative ion? Now, if you remember from our previous discussion that we talked about, if you are negative, for you to have an ion that is negatively charged. So for you to have an ion that is negatively charged, then it simply means the number of electrons should be greater than the number of protons. So you should have more electrons than protons. So you can just look at that, which one has got more electrons than protons. So more electrons than proton. If I can see here, these electrons are 10, protons are 12. No, that does not qualify. Here electrons are 10, and that's 8 here. So you can see that particle T has got more electrons than proton. So therefore I can simply talk about particle T is the answer. What is the reason? You can simply say because electrons are more than, I'm using greater than, electrons are more than what? Are more than protons. So because electrons are more than, so you can write that in a statement form, electrons are more than or greater than what? Protons. That's the reason why we are saying that. That's the reason that you could have given. Then I included this question, it was not there in the exam, it was saying which particle is a positive ion. So from there, which one is a positive ion? Well, when it comes to those ions that are positive, we said for those that are positive, you're going to find that the number of protons will be greater than what? Electrons. So for those that are positive, for those ions that are positive, it simply means that protons will be greater than electrons. So you just need to look at which one has got more protons than electrons. Of course, you can see that R has actually more protons than electrons. So here in this case, R was going to form a positive charge. All right, here we have not actually computed that. The question was saying, quite all right, we have established that it is T, but it was saying state the charge. In other words, they wanted us to, what is the charge that it actually carries, T carries. If you notice, from there were how many protons? 8. It has now 10 electrons, meaning how many have been added? 2 more. So meaning that it has a charge of -2 or 2 minus if you want. So that's the charge that it has, 2 minus or a -2 there. And what's the charge that R is going to have? Well, if you look at this one, it had 12 protons, but now the electrons have reduced to, remember initially the number of protons and electrons were the same, so now they have reduced to 10, so meaning that it will have a 2 positive, so it will have a 2 positive because it has lost 2 electrons. No wonder the electrons have remained, as 10 there, so 2 positive. And then D says, which 2 particles are isotopes? Remember, isotopes are atoms of the same element having the same proton number but different mass number. So atoms of the same element, they have the same proton number but different neutron number. So which one have got the same proton number? If you notice, these guys have got the same proton number, and you can see they have got different number of neutrons. So therefore, if I talk about P and Q, those are what we are simply calling as being isotope. Give a reason for your answer. The reason is very simple. They have the same number of protons but different number of what? Different number of neutrons. So here you could have actually said, they have the same number of protons. So they have the same number of protons but different neutrons. So that's the reason that you could have actually given there. Then the last but not the least says use the periodic table. So they want you to use the periodic table to identify particle R. So now how do you identify particle R? You just need to know, in this case, what is the total mass. So when you add the number of protons plus the number of neutrons, it will give you the mass. In other words, what we call as being the mass number. So you just need to add. So when I add, in this case, protons and neutrons, it is going to be 12 plus 12, it will give me 24. When you go on the periodic table, the one which has got the relative atomic mass of 24, the element is simply magnesium. So magnesium Mg, on top it has 24 and the proton number 12. So magnesium was simply the element that they wanted you to look at. So thank you so much. Please, you can watch out next time as I try to introduce a new topic. I'll try to look at valences, formulas and equations. So those are things that I'm going to look at. Thank you so much for watching. Please make sure that you go through. If you like what I do, please, you can subscribe and hit that like button. Thank you so much for watching.